Welcome to the last video in this batch. Today, webhooks, the mechanism that lets outside services notify your app the instant something happens. Payment succeeded, code pushed, message received. Once you see the pattern, you'll notice it holding half the internet together. Start with the problem. Your app charges customers through a payment provider. A payment can take seconds or minutes to clear. So how do you find out when it does? Option 1. You keep asking. Every 5 seconds, your server calls their API. Anything new? No. 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 Yes. That's polling, and it's how you'd naturally build it. But look at the waste. Thousands of calls that return nothing. And even so, your news is always up to 5 seconds old. It's refreshing your inbox all day instead of getting a notification. Option 2 flips the arrow. Don't call us. We'll call you. You give the provider a URL, and the moment the payment clears, they send a request to you. No wasted calls, near instant news. That reversed arrow is a webhook. If Video 3's real-time subscriptions rang a bell, same push philosophy, but webhooks work server to server between totally separate companies. Here's the demystifying part. There's no new technology here at all. A webhook is a plain HTTP post request, the same kind your own services send whenever they call an external API, except the direction is flipped. An external service sends it to a URL you registered with them. The body is usually JSON describing an event. What happened, a unique event ID, and the relevant data. That's the entire invention, an agreed-upon direction reversal. You expose an endpoint. They call it when something happens. Everything else in this video is just doing that responsibly. On your side, a webhook receiver is just a route. Accept the post, look at the event type, do the right thing. Here, mark the order as paid, and respond with a 200 so the sender knows you got it. 2 habits separate a toy receiver from a real one. First, respond fast. The sender is waiting on your reply, and most will treat a slow answer as a failure. So acknowledge immediately and push heavy work, emails, PDF generation, onto a background job instead of doing it inside the request. Second, and this one is a genuine security issue, notice that as written, anyone who discovers this URL could post a fake payment succeeded and get free products. Which brings us to signatures. Every serious webhook provider solves this the same way. Signatures. When you register your endpoint, you receive a shared secret. The provider computes a cryptographic signature of each payload with that secret and sends it in a header. Your code recomputes the signature over the raw body and compares. Match? Genuinely them, untampered. No match? Reject with a 401 and move on. You will rarely write this crypto yourself. Providers ship SDK helpers that do the verification in one call. The rule to remember is simpler. An unverified webhook endpoint is an open door. Verify first, then act. Always. What if your server is down when the webhook fires? Good providers retry. A minute later, 5 minutes, an hour, with growing gaps. Which is great news, and also a trap. Retries mean the same event can reach you twice. Maybe your first attempt succeeded but responded slowly, so the sender retried anyway. If your code blindly processes both, you've shipped one order twice. The fix is idempotency, a fancy word for processing the same event twice must have the same effect as processing it once. And the unique event ID makes it easy. Keep a record of IDs you've handled. When an event arrives, check first. Seen it? Acknowledge politely and do nothing. This tiny guard clause is the difference between a webhook integration you trust and one that double charges a customer at 3 a.m. One practical snag before you meet this at work. Webhooks are sent over the public internet, and your laptop's local host isn't on it. The standard fix is a tunnel. Tools like ngrok or Cloudflare Tunnel give you a temporary public URL that forwards straight to your local port, so real webhooks reach the code you're editing. Many providers also ship CLIs that do this for you and can replay test events on demand. Replay beats waiting around for a real payment every time you want to test a handler. Recap. Webhooks reverse the arrow. Instead of polling, Services post events to a URL you expose. A receiver is a simple route, but respond fast and defer heavy work. Verify signatures because an unverified endpoint is an open door. Expect retries and make handlers idempotent using event IDs. And tunnel to localhost while developing. That closes our 5-video batch: databases, Docker, Supabase, caching, and webhooks. You now have the backend vocabulary to hold your own in any architecture discussion. See you in the mentor lectures.